so 722, we're going to look at these parameters on that cyclic function. So yesterday you guys went through with sine, and I made you guys play around with decimals to sit there and see if you could move some things around, how to shift it up, shift it down, shift it left, shift it right, flip it over, shift it all around, right? Doing all of those transformations. So today we're just going to kind of wrap up with that and kind of talk about those parameters and like what each one of those kind of mean, right? So yesterday, well, let's write some of these out, right? So I had you guys start off with that parent function. We said, ooh, I don't want that big old thing. There we go. Y equals, we just said like sine of x, right? So then I had you guys do like y equals sine of, and then I said do x, neither like plus or minus a number. So like if we did like plus 2, and then we sat there under our little decimals. Uh-oh. So we had our sine of x. Fighting with it, I'm fighting with it. There we go. Right? Oop. Some days, right? There we go. Close enough. Right. So we had our sine of x. Right? So if we had our little wave. So then I said to do, and then what did we have? X plus, oops, oh my. X plus, what do you think is going to happen when we add something to it? Like 2?
It's going to move it over to the left.
Yeah, it's going to move it over to the left. Yep, good job, right? And then we tried, so what did we go with next? Then we did like y equals sine of x, but then let's say we still use that plus 2, but that plus 2 was not in the parentheses. And then so when we messed around with that little guy on decimals, so we'd have our sine of x, but now we're going to add 2 to it. What do you think is going to happen?
It's going to move up.
Yeah, it moved the whole entire graph up, right? Very nice. And then we even tried it with the number out front. So let's say we just put 2 out front, 2 sine of x. So then under our decimal, if we put a 2 out front, what do you think is going to happen?
Like compress or stretch.
Yeah, which one do you think it's going to do? Do you think it's going to compress it or stretch it?
Probably stretch.
Stretch. Yeah, and that's what it did, right? What if it was like 0.25? What do you think it's going to do?
It's going to compress it.
Yeah, then it's going to compress it down, right? So if it was between that 0 and 1, yep. Sweet. So just like when it came to our quadratics, if we look at this equation, when we did quadratics, we had an a out front, right? We had that h along with our x in that parentheses, and then that k on the outside. And so it works the same way when it comes to any function. So it's going to work the same way when it does with the sine function or cosine function that it did like with our parabolas or our quadratics. So let's write a few of these. Feeling colorful today. Well, I gotta go a different color. We'll go pink. We'll go pink. Right? So this a out front, if our a is greater than 1, it's going to stretch the whole graph. If our a is between 0 and 1, so if our a is greater than 0 but less than 1, oops, let me make this bigger again. There we go. So in other words, this would be like a fraction, right? We know then it's going to compress our graph down. What happens if a is negative? We didn't do that one. What happens anytime we have a function and we put a negative out front? Does it flip it over the x-axis? So if it's negative, it's going to flip it, right? Let's talk about our h. So if our h is, we'll say a positive h, so if I put in a positive h, I'd have like x minus 2, right? So for example, it would be x minus 2. And this is going to move it to the right. If it was a negative h, so like x minus a negative 2, which would give us x plus 2, that's going to move it to the left. And last but not least is our k. So we said a positive k was going to move it up. And what's a negative k do? Moves it down, right? So then now when it comes to sine functions, we can move our sine functions around and be able to graph them as well, right? All right. So one other little thing when it comes to, oh, how'd that get moved? Can I move it? There we go. Ooh. When it comes to our functions, when it comes to these trigonometric functions, they're called cyclic because they form a cycle. And a cycle is something that goes over and over and over and over and over again. So when it comes to our trig functions, we have this thing called a period. And this is like finding, it's like the distance of one cycle. So when we started doing these, we went all the way around the unit circle, right?
Yeah.
And when we went all the way around the unit circle, it was 360 degrees, or it was how many radians? 2 pi, right? So if we have a unit circle, our period is at 2 pi, but our unit circle would be where, like, we just have like sine of x, right? So if I started at 0, and that's where I repeat, right? That would be one cycle. So my cycle would be 2 pi. So this would have been like when y equals sine of x, right? But we just learned now that we can kind of change some of our equations around, and we can put numbers out front, and we can move them left and right and up and down. And when that happens, sometimes our period gets changed. So if I look at the next graph, how far do you think it takes in order for me to go through one cycle? If I started at like 0, 0, I'm trying to get back to that point to where my function is going like a positive slope right there, right? So if I start here, would this give me one cycle? No, because my slope is still negative, right? So if I go from here and I go all the way around, then I get to here. Is that repeating? Would that be one cycle? Because it's almost like if I got this guy, right? It's probably hard to see. Are those repeated?
Yeah.
Right. Does that make sense? So how far did it take me to get through one of these? It took me, this one is until pi, right? So then my period would be pi. And it can be more than 2 pi, it can be less than 2 pi. And it all depends, like you can pick where you want to start to measure these, but I think the easiest is starting at 0, because then you don't have to subtract anything, right? If you start at 0 and figure out until where it goes and repeats, then you're pretty good on it. Does that work?
Yeah.
All right.
Is that everything?
That is everything. Yep, so on your guys' assignment, I know they give you a couple like little graphs and they want you to try and come up with the equation on that, right? Oh, your A, I'll help you out because I wonder if they did it. Let me add this real quick. The other part when it comes to our graphs are these things called amplitudes. Oops. An amplitude is kind of, it's sort of like the height, but it's the height of, these things all go like above and below, like for this example, like the x-axis, the same amount, right?
So it's kind of like a sound graph?
Yeah, yes, yep, absolutely, yep. And then this is also going to be like our radius, right? So as high as I went is 1, like the lowest I went is -1. But if I think of it as a distance, that distance is 1, right? And the distance going down is 1. So for example, on this one, my amplitude would equal 1.